Question 1 of the first formative assessment for term 3. Prove that if R is a rational number, Q is rationals, and Rx is irrational, then X must be irrational. Now, there are a couple of ways you can prove this, but I think the easiest by far is the proof by contradiction. And so that starts by making an assumption that is the negated statement to what we're given. So we're saying, let's assume that X is actually rational. And if X is actually rational, then X is equal to some fraction. Might be a whole number where B is 1, but it could be a fraction as well. And we also know that R is rational, so it's also equal to some fraction. And then therefore, XR will be equal to A over B times C over D, which is equal to AC over BD, which is also a rational value because I'm making the assumption here that A, B, C and D are all integers. That's the only way to get the rational numbers, is that the fraction is formed by integers. And A, C and BD must also be integers. And therefore AC over BD is irrational, and therefore Rx is a rational number, which is a contradiction. I've only made one assumption in the question, and therefore that assumption must be wrong due to the contradiction, and so therefore X must be irrational. That is the shortest and easiest proof. But the contradiction one, you didn't see that like we did proof in the last term's exam, but I don't think there was a contradiction proof in there. So I just wanted you to see that and remind you of that. The important thing here is to make sure that you do define all these values and you state where they're from. The other important thing is to recognise that when you read that question, it's actually almost obvious. You're looking and go, well, the only way that it can be an irrational number is if one of those numbers is irrational. You can't get two non-irrational numbers to multiply to give an irrational number. So it's almost obvious. You've got to be careful your proof doesn't take the form of something that's basically just saying, oh, because it's obvious. So, and that's a really easy trick to fall into. Your proof has to be exact, precise, and flow logically to show that there's no other way it can be anything else. So just be careful of that. That's question 1. Mark allocations. It would probably be 3 marks in an exam. And the marks would probably be allocated if, keep in mind there's other solutions. I'll just be a second, Max. There are other possible solutions, but in this solution, I would probably allocate marks, a half mark for the assume, and a half mark for defining your A, B, C, D, or whatever that you've got equivalently, and then a couple marks for building through to this, and then a half a mark for your contradiction and a half a mark for the result of your contradiction, something along those lines. There will be a mark allocated or half a mark allocated somewhere for your definitions, and then it will build down from there. Max?
Do you have to say that AC and BD are integers? Isn't it given because...
You should. Technically, if you're making a statement that X is irrational and equals A over B, then the assumption is there that they're integers, but really you should be making that statement.
Okay.
So,
you've already mentioned that A, B, C, and D are integers, so why do you have to say
here, yeah. Oh, I see what you mean, yeah. So if you mention that, do you have to say this?
Yeah.
Not really, but it does help with the flow a bit. So it's just that kind of, every time you get to a point where you're trying to show something's rational, show that it's fraction in the form of integer over integer. It helps the flow. So question 2, if 10 people are in a room and each pair shakes hands with each other pair, or with each other, sorry, how many handshakes took place? So this is actually a pretty common sort of problem solving question that we give to students in year 7, 8, 9, 10 to have a play around with. You can do this logically, and you may have done it logically. So the logical approach is, there are 10 people in the room, the first person shakes hands with 9 other people. In fact, everybody shakes hands with 9 other people, but each handshake is a double count because there are 2 people involved. So you do 10 times 9 divided by 2, that gives you 45. And I wouldn't stop you from getting full marks if you've done that logical approach. But the approach from the specialist math course is this. Each handshake involves 2 people. So each different handshake is basically how many ways can you choose 2 people from that group of 10. So the answer is actually 10C2, which is equal to 10 factorial over 8 factorial 2 factorial, which is equal to 10 times 9 over 2, which is the number we got from our logical approach, and so that's equal to 45. There are 45 individual handshakes. And again, the mark allocation here, and you'd have to flow this across to that logical approach. It would probably be a 2-mark question. It's pretty short. And your first mark would be for the design, the setup, and this mark would probably be allowed if you did a logical approach and didn't divide by 2. So if you come up with an answer of 90, you'd probably get 1 mark. And then the second mark would be for the right answer. That's about the breakup that I'd expect to see there. And you can see I've probably given myself a bit too much space here. So there's the second one, give yourself marks. The next one, that's not what I want. Let me do that again. So you're given a vector, you need to determine the A hat. What's A hat represent? The unit vector. So we're determining the unit vector, and the unit vector A hat is equal to the vector divided by the magnitude. And I've walked around the room, I'm assuming the magnitude is root 74 since I saw that, but I'll do the calculation. The magnitude of A is equal to the square root of 7 squared plus negative 5 squared. There's really not, in specialist maths, there's not really going to be a mark allocated for this, but it's technically wrong if you put 7 squared plus 5 squared, because the negative goes with that 5. So you just got to be a bit careful with that. Yep.
You don't have the hat on the thing.
Oh, no, you're right. Yeah, don't have the hat there. He'll get sunburnt now, and it's all your fault, Connor. So that's root 74, and so therefore A hat is equal to 7i minus 5j over the square root of 74, and I'll take that in many different forms. Some of them could be the square root of 74 over 74 times 7i minus 5j, or, sorry, that's failed on me. That's failed on me. I've left my other one down on my desk. There we go. Or I would take 1 over root 74, 7i minus 5j, or I would take the expanded version of either of those. Four different options I'd take. So I can hear people talking, but I'm not sure if there's a question. Part B. Determine vector B in the direction of A with a magnitude of 10. This actually, for me, from my point of view, I read this question and I'm straight away thinking this is a bit complex, I've got to really think about this. It's actually pretty easy. A is in the direction of A with a magnitude of root 74. A hat is in the direction of A with a magnitude of 1, and therefore vector B will be equal to 10 times vector A hat, which will just be 10 root 74 over 74, which you can simplify, but again, I'm not really testing your fractions. So whilst I would expect you to simplify and make that 5 over 37 and do something like that, it's probably not the end of the world. It is a problem in methods or specialists where you can actually do some cancelling out algebraically, but with numbers, there won't be a mark allocated for that in a simple question like this. So I would say that this question would be 3 marks, maybe 4 if you're lucky, and it would be a 2,1 question. So I'd allocate half a mark for recognising the A hat rule, and then probably a full mark for finding the magnitude, and the other half a mark for a correct solution. And for part B, I'd give half a mark for the 10 times A hat, and then half a mark for the correct solution. Any questions on that?
What if you put it in polar form?
In what form?
Polar.
I would give you the full mark, and then I'd probably question why you wasted your time. And question 4 looks like this. In the following diagram, CB is parallel to DE. So I've got that is parallel to that. Now I've taken this straight from a practice exam from a different textbook, and I've copied that diagram exactly. And their diagram didn't have those arrows on. I'm translating the information from the question straight to the diagrams. It's important to me to recognise that and to not make assumptions. O is the centre of the circle, BC and BA are tangents. It makes a statement, and you've got to be careful you don't assume it, although O is usually the centre. What that means is that OC, OE and OA are all equal. They're all radiuses. So that could be an important factor later on. BC and BA are tangents, which means that they're also equal in length. And points at points C and A respectively. So given that BC and BA are tangents at C and A, that's a right angle, and that's a right angle. That's given as well. Calculate AOE. So we need to calculate this angle here. So I'll call that X. Now I know that that is essentially, if I need it to be, it's inside a isosceles triangle. That might help me. But just mapping out some other options, I know that this angle from the centre bisects this side here. And that's one of our circle rules, but you can also use congruency to prove that. But from the centre, that bisects the 50. And I've got 25 and 90, which gives me 65 here. I've got 25 and 90 there, so that gives me 65 there. Where else can I go here? Can I work out this angle?
Yeah, because it's 90 degrees. 90 minus 65.
So that is, this angle here is definitely 90 degrees? Okay, cool. So if these two are parallel, then, and that's 90, that's the co-interior angle. Yep, good point. 25 there. And so I've done my mapping. And I'd kind of expect you to do this, particularly with a complex question. I'd expect to open your exam paper and find you've drawn all over the diagram to build a path. So my path is now going to be that I'm going to first make the statement that this is bisected, and then I'm going to show that 65 and 65 exist, and then I'm going to do that parallel lines gives me 25 there, and then I'm going to show that X is equal to 40. So that's going to be my map. So I'm going to say angle CBO equals angle ABO equals 25 degrees, and the line from O bisects angle COA. So I've got that. Then I'm going to show angle OCB is equal to angle OAB is equal to 90 degrees, and they are angle between radius and tangent. So that's going to be important. And then I'm going to say, therefore, angle COB is equal to angle AOB is equal to 65, and this is the angle sum of a triangle. And then I'm going to make the statement here that angle COE equals 90, and this is co-interior angles. CB is parallel to DE, and that's given. And I'm therefore going to say, therefore, angle BOE is equal to 25 degrees, and this is angle sum 90 equals 65 plus 25, and therefore angle AOE equals 65 minus 25, which equals 40 degrees. And that's my final solution. Generally speaking, with a circle theorem question, a long-winded one like this will still earn you some good marks, probably 4 or 5. Usually I'll give a mark for each stage of the proof. Half a mark for the actual statement, half a mark for the proof statement, the thing in brackets. This one here drifts off a little bit to some simple stuff at the end. So I think we'd probably go 5 marks. And it would be half a mark for that, 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 and then half a mark for this and half a mark for that. Max.
What's the point of mentioning COA, sorry?
COB. E. I need to show that's 90.
What?
So that I can do 90 minus 65 is 25.
V thing we went through it.
Oh, okay.
What would you parallel Z.
I,
Corresponding in a Z.
you just have to, so the line from the centre of a circle bisects two tangents. So it bisects the angle at the two tangents, where the two tangents meet.
As in CBO equals BOE. What would be the bracket justification for that?
CBO equals OBA, you mean?
No, CBO equals BO.
Oh, so you could do that to that.
Yeah.
That would be
So
alternate
like
alternate angles.
alternate angles.
Yeah, you could do that. Oh, that's a good point. So you could do the alternate angles. I missed that.
Yeah.
Um,
That's what Max did.
same marks allocated slightly differently. I might just stop the video, Connor.